Assignment 7 and 8, multiplying polynomials. Welcome back, guys. For today's lesson, one thing you need to remember is, of course, when multiplying exponents, remember, you're only multiplying the coefficients and you're adding, of course, the exponents. So, multiplying. Let's start off with some examples of problems you're going to see in both 7 and 8. So, example problem 1. Let's start off with 6v and it's being multiplied to 2v plus 3. Now, this type of multiplication is, of course, distributive. You're going to distribute the 6v to everything on the inside. And we start this off as multiplying. 6 times 2, that's 12. And notice they have the same base. So v, it has to the power 1, v has the power 1, so 1 plus 1 is 2, so that is 12v squared. Last but not least, we have 6 and it's being multiplied to 3. 6 times 3 is 18. This one has a base, this one does not. Since this one only has a base, you just write it out and you're done with example problem number 1. Alright, let's move to example problem number 2. Let's throw in a negative. So example number 2. Say we have negative 4 and you're multiplying it to v plus 1. This one is different because the negative 4 doesn't have a base, but it still means multiplication. So this is a distributive multiplication. So negative 4 times v is negative 4v. And the last one is just a straight multiplication. Negative 4 times 1 is negative 4 because a negative times a positive is always a negative. Example problem 2, complete. Let's go ahead and move on to number 3. Number 3 is something that should remind you of what you did in Algebra 1. So let me go ahead and write out both of them. I have 2n plus 2 and it's being multiplied to 6n plus 1. Here's the big difference. Instead of just having a coefficient over here on the outside, distributing, now you have a whole set. When doing this, you have to use a method that is called box method. So let me go ahead and draw out my box. And then here we go. Let's label each one. This is going to be 2n, which is this one. The 2 down here, because they're together. And then I'm going to write the top one. 6n and then 1. Now, the question you can have, Mr., what if I have the 6n plus 1 on the left side and the 2n plus 2 on the top? It doesn't matter. You're still doing the same thing. So let's begin. 2 times 6, that's 12. This has an n, that has an n. There's a total of 2, so n squared, because I added them, right? Adding exponents. 2n times 1, that's just 2n, because 2 times 1 is 2. That has a base, that does not. So write it right there. 2 times 6, that's once again 12. That has a variable or base. This one doesn't, so it's just n. And last but not least, 2 times 1, that is 2. And then, of course, we combine like terms. The first box is always the first number we write out. So 12n squared. This one, complete. So from here, the ones that are always across from each other, you always combine. 2 plus 12, that's 14. And of course, what makes them the same is n. This is done. This is done. All that's left is 2. Go ahead and box both. Example problem number 3 is complete. Now, let's go ahead and do another example. Example problem number 4. On example problem number 4, I'm going to start off with 4p minus 1 and it is squared. Now, this one, some of you guys are getting nervous, mister. You didn't have nothing on the outside. It's squared. What does that mean? Whenever it's squared, that means it's the same thing written twice. So this one is just like example problem number 3. That means there's just 2 of them. There's going to be 4p minus 1. Let me go ahead and fix that p. And this one is also 4p minus 1. And now we set up our method, which was box. So let me go ahead and draw my box. So this is going to be 4p minus 1, 4p minus 1. 4 times 4, we know that's 16. There's a p there is a total of 2. So we add them, which is p squared. Remember, adding the exponents, not the p's. So 4p times negative 1, multiply our coefficients, which are both positive and a negative, so that's a negative 4 and p. Negative 1 times 4p, that is negative 4p. Then negative 1 times negative 1 is 1, because 2 negatives give you a positive. Now, first box immediately goes to our answer, which is 16p squared. And then like terms, the ones that are always across, you always combine. Negative 4 minus 4 is like you owe money to 2 people. You add them and keep the negative, so it's negative 8p. Last but not least is that 1. The 1, of course, notice there's nothing right there, so it is a positive, so plus 1. Let me go ahead and box it, and you are done. Let's go ahead and continue 2 more examples. So example problem number 5. Number 5 is one of the difficult ones you're going to see on the problems, but it's the same thing as 3 and 4. So example problem number 5, you're going to have 2n minus 4 times n squared plus 6n minus 4. There is a difference. Now for this one, you can still use the box method, except the box is going to turn into a rectangle. Oh, here we go. Ooh, I drew that wrong. Let me draw this a little better. Draw one right here and right here. One across the middle, and let's begin. So we're gonna have 2n minus 4. I'm gonna have n squared right here. I'm gonna have 6n and negative 4. And now we're gonna multiply all across. So 2n times n squared, 2 times, well, there's a leading coefficient of 1 there. 2 times 1 is 2. We add the exponents. 1 plus 2 is 3. 2 times 6, that's 12. They both have an n. We combine the exponents, that becomes n squared. 2n times negative 4, that's the only one with a base, so 2 times negative 4 is negative 8, and of course the base is n. Now bottom, negative 4 times n squared, the coefficient is 1, so negative 4n squared. Negative 4 times 6n, once again, that has a base, this one does not, so that'll be negative 24n. Then negative 4 times negative 4, we're multiplying 2 negatives, so that turns into a positive, so 16. And now, the first box immediately towards your answer, so that becomes 2n to the third, or 2n cubed. Then, the ones you always combine are across from each other. See, n squared, n. They're always across. So let's combine them. This is done. So 12 minus 4, that's 8. So plus 8n squared. This is gone. This is gone. And from there, the next letter cross. -8 minus 24 is, like I said, like you owe money to two people. You combine how much you both owe. So -8 minus 24, that is -32n. This is done. This is done. All that's left is that +16. So I write it out. And your answer to example problem number 5 is on the board. And last but not least, example problem number 6. On example problem 6, you're going to get a little bit of these, but it's almost the same thing. So let's begin. Let's say we have, this is number 6. Let's say we have 4a and it's being multiplied to 5a squared plus 3ab minus 5b squared. This one you can just assume and know that it's going to be distributive because we have something on the outside. So this one multiplies to everything on the inside. So let's begin. 4 times 5, that is 20. Base and base, they're both the same thing. So that has 1, that has 2. You add them, that gives you 3. Next, 4 times 3, we know that's 12. And we add the bases together. That has an exponent of 1. That has an exponent of 1. So that is a squared. Then you say, Mister, what about the b? This one doesn't have a b. Just because it's not there, you just drop it down. Just leave it alone. It's not bothering you, right? So just drop it. Next one. 4 times -5. We know that's a negative, so that gives us -20. And a's right here, and a is not. Once again, if it's not there, just leave it alone. Just drop it. So I'm going to just put a. And then this one doesn't have a b, but that one does, so just put b squared. Combine them, and you are done. Any questions? I believe not. And that should be it, guys. With that being said, go ahead and give me a like and subscribe to my channel. Have a good one.